So in this video, we are proving the 10 chord theorem. Well, it's self-explanatory. So whenever you have a tangent, right, and then the tangent meet a chord, so the angle between the tangent and the chord, as you can see, the angle here is x, and as you can see, your chord produce an angle at the circumference of 50. Now the theorem states that the angle between the tangent and the chord is equal to the angle subtended by this chord here, which is 50. So knowing that theorem is not enough, as you will have to know how to prove it as well in grade 11 and grade 12. So today we are proving it, right? But now in order for you to prove it, just always, you're going to need your construction, and not only your construction, but what other theorems will you need to have in order for you to prove that DBC, so you have to prove that this angle is equals to BED is equal to that angle there. What I just showed you, the angle between the tangent and the chord is equal to the angle subtended by the chord, right? So here are the theorems you're going to need to understand. Is that angles in the same segment. So if you have a segment, you see that blue arc there, right? It produces these two angles at the circumference, and you should know that those two angles will be equal. And then you're going to need two 90s. You're going to prove the first 90 using the 10 perpendicular to radius, and then the second 90 is going to be angles in a semicircle. What does that mean? If you have a diameter of AB, a diameter will always produce an angle of 90 at the circumference, right? So these are the two 90s, and then you're gonna need that one. So let's not make it big. So let's not make the video long. So the thing I will do first is you just construct. So you construct a line through the middle. Make sure it's yes through the middle. And then remember, the letters you're gonna use is up to you. So I'm gonna use a letter that is not in here, which is, I'm just gonna say F. And then what you do after that, just hold on. So you draw your diameter, right? And then you join it like that and form that type of chord. So you're going to join B, F. So that's your construction join, B, F. And after you join B, F, what did you do? You joined E, F, right? And E, F. So that is your sketch, right? So because you did that, now you have angle 1 and 2 for B, and then you have angle 1 and 2 for E. So now, remember, this is a tangent, right? Remember the line from the center to the circumference. What is that? A radius. So I can say B1 plus B2 should give me what? 90 degrees. And then my reason for that is tangent is perpendicular to radius. So tan perpendicular to radius. That's my first 90. I need two 90s. So this is my first one. And then 2, what do I notice here? This is a diameter, right? And what did I tell you about a diameter? It will always produce an angle of what? Of 90. So I can say E1 plus E2 also is 90. But the reason is going to be angle in a semicircle because it is produced by what? By the diameter. So angle in a semicircle. So I have two 90s for this proof. Now the third one is going to be the angles in the same segment. So now I want you to focus on the following. So you see this arc here. So that arc produced this angle here. Can you see it? Which is B2. Now the same arc, which is this one, produced this angle, which is E2. Can you notice this one and that one? Do you see it? So I can say B2 is equals to E2. Reason for that? Angles in the same segment, right? Therefore, that would mean B1 is equals to E1. You're probably thinking, how? What is the reason for that? Well, the reason for that will be easy. You've just proven it. You've proven that b1 plus b2 is 90, right? And you've proven that e1 plus e2 is also 90. And then you've proven that b2 and e2 are 90. So you've proven that this one and this one are equal. So automatically, these two also becomes equal because you've just proven that these two are equal. So if these two were like 80 and 80, then these two will be 10 and 10 because when you add these two, they should give you 90. So that's how you prove the 10 chord theorem. So if you ever got lost somewhere in the steps, watch again and then try practicing it a couple of times. If you don't see it in the beginning, it's okay, but try practicing it a couple of times. And like I always recommend, just change the letters and then try again without seeing it a couple of times. And then obviously if you get it wrong, you just go back, see where you went wrong. But this is actually how you get your easy 5-mark questions. So hope this was helpful. See you in the next one.